Hello student, today we're going to talk about diffusion. We're going to talk about the definition of diffusion as well as the factors that will affect the rate of diffusion. By definition, diffusion means that the spontaneous net movement of particles sounds their concentration gradient. The word spontaneous in this context means that this process does not require any additional energy. But what does the down the concentration gradient means? Let's look at a daily example on what it means by moving down the concentration gradient. Here we have a lump of sugar. It is composed with many individual sugar molecules. When the lump is dropped into the water, it begins to dissolve. The yellow balls represent a sugar molecule in the lump of sugar. The sugar molecules move from places where there are lots of them to where they are scarce. When molecules move from area of high concentration to area of low concentration, it is called diffusion. Diffusion continues until all the sugar molecules become evenly distributed throughout the beaker. But what does it mean by the net movement of particles? Let us look at a visual representation of how particles collide with each other during diffusion. During diffusion, particles are moving randomly in all directions when they collide with each other. Therefore, when we say net movement, it indicates that there are more particles moving down the concentration gradient than those that accidentally went up the concentration gradient. So what happens when diffusion continues? Particles will continue to move around randomly, and they tend to distribute evenly after some time, which result in an indifference in the concentration gradient. So what happens when the concentrations are the same and no longer different? From the picture, we can see that the particles, as represented by the purple dots, are distributed evenly, and the arrow indicates that they are still moving around randomly. However, does this count as diffusion? Student, let's check our concept of diffusion now. Do you think diffusion is still happening after the particles are distributed evenly and there is no difference in the concentration gradient? If you're unsure about the answer, you can go back to the first slides of the video to revisit the concept of diffusion. The answer to this question is no, because diffusion means the net movement of particles. When the particles are distributed evenly, there are no longer a net movement of particles. Therefore, even the particles are still moving around, diffusion does not occur. Now that we have gone through how diffusion occurs in liquid medium, let's also look at how diffusion happens in gas state as well. Have you ever thought about why you're able to smell hot food? How does the smell of that food reach you? When the food is cooked, it released some aromatic gases into the air. The gas molecules spread and mix with air. When the air reaches our nose, we get the smell of food. This is an example of how diffusion happens in gas state. This example also tells us a factor that increases the rate of diffusion. Heating food enables gas molecules increase in temperature and gain kinetic energy. When gas molecules vibrate faster, it increases diffusion rate. On the other hand, for cold food, kinetic energy of gas molecule decreases. That's why it does not vibrate as much. And thus the rate of diffusion decrease. Therefore, we cannot smell the food from a distance. Let us look at the diffusion in daily example. If you want to make a cup of chocolate milk from chocolate and milk, how would you make the process faster? When you heat up the milk, the kinetic energy of the particles increase, which makes the particle collide more frequently. This can increase the rate of diffusion. Smaller particles have a higher diffusion rate than larger particles. The rate of diffusion is not only limited by the particle size, it is also related to the physical size of the matter. When you cut the chocolate into smaller pieces, it also increases the surface area to volume ratio, which can also increase the rate of diffusion. Remember the definition of diffusion? By adding more chocolate, you can increase the concentration gradient, which makes diffusion happen faster. Besides the three factors that we just mentioned, a shorter diffusion distance can also increase the rate of diffusion. Because the particles will take less time to travel down the concentration gradient, therefore it will reach the indifference in concentration gradient faster, and thus a higher rate of diffusion. Let's conclude on the factors that can increase the rate of diffusion. For the factors that affect the rate of diffusion, you can always revisit the two examples of hot soup and also chocolate milk to help yourself remember better. See you next time!
created using Powtoon.